we'll discuss vertical alignment. Now in the beginning of this session I told you that road is a 3D element, and usually what we do is we project it into two projections. One is horizontal alignment, then the other one is vertical alignment, right? So now we discussed all the theories or the basics of all the theories in horizontal alignment, and now we are going to we are going to discuss on vertical alignment, right? So that is the vertical projection in of the 3D road elements. Now the vertical alignment is necessary for the determination of the elevation of highway points to ensure proper roadway drainage and an acceptable level of safety. Okay, you know why vertical alignment is necessary, because that is the to determine the elevation of highway points, right? To ensure proper roadway drainage and acceptable level of safety. Level of safety, of course, we discussed last day. The transition of roadway elevation between two grades is the primary challenge of vertical alignment. So what is the primary challenge of vertical alignment? That is to transition of roadway elevation. Okay, the transition is effectively achieved by means of a vertical curve. Now you can see there is a vertical curve here, right? This is the vertical curve. Again, this one is also a vertical curve. Usually, the longitudinal profile of a road consists of straight gradients and vertical curves. Okay, so now as same as an horizontal as a horizontal alignment consists of straights and circular curves, here in the vertical alignment we have straight gradients and vertical curves. Remember, vertical curves are parabolic, horizontal curves are circular. Okay, now you can see the function of a vertical curve not only limits to smoothing the passage of a vehicle from one gradient to another, but to increase the side distance, right? Now you can see here, now here one grade here, another grade here, and you are having a vertical curve. If you had the vertical curve like this, what will happen? Then your side distance will be increased. Or instead, you could have the vertical curve like this. Then what will happen? Your cost will be minimized, but what about the the side distance? It will be reduced. So there should be a balance, right? The function of a vertical curve not only limits to smoothing the passage of a vehicle from one gradient to another, but to increase the side distance over crest at the junction of the gradients, right? Then vertical curves can be broadly categorized into two categories, namely crest vertical curves and the other one is sag vertical curves. What is crest and sag? So this is crest, this is sag, and we are going to discuss them in detail. So first of all, we'll discuss what are some of the general considerations of vertical alignment. The following general controls for vertical alignment should be kept in view in designing the vertical profile of a road. The selected grade line shall be smooth with gradual changes consistent to class of the road and terrain type. What is this consistent class of the road and terrain type? Now that means, now you know we have three terrain types. What are they? Flat, rolling and mountain. And we have classes. What are they? A class, B class, C class and D class. And there is expressways also, right? So depending on these things, the side distance are going to be different, right? And and then other parameters, gradients are going to be different. So they should be, our vertical alignment should be consistent to class of the road and terrain type, like that. The two vertical curves in the same direction separated by short section of tangent grade should be generally avoided. Okay, so you call them you know they are not very proper, and they are not very handy for a proper road. On long grades, it may be preferable to replace the steepest grade at the bottom and flatten the grade at short intervals, so lighter grade instead of uniformly sustained grade. So I'll describe this. Okay. What they are telling is, instead of sustaining a grade like this, you can do it this way. Instead of sustaining a grade like this, here it is steeper grade, and the steepness of the grade becomes reduced along the grade. So that is what they are asking you to do. So here you can have curves. Why? What is the difficulty here? It is difficult for drivers because it is sustained grade. Difficulty is same, but here what happens? In the first sections it is bit difficult, and then it becomes easier, and finally it becomes more easier. Okay. Now these are some of the general considerations that we are going to discuss. Hidden type of profile should be avoided as it is hazardous and aesthetically unpleasant. Can you see here? This profile is hidden. Okay. And maybe you can call it roller coaster. Why it is roller coaster? What is a roller coaster? Now in theme parks, have you seen roller coaster? It is going up, going down, up and down like that. So it is called a roller coaster. So a road should not be designed as a roller coaster, or this is called a hidden dip. Okay, because you don't see that. It's called hidden dip. A roller coaster vertical alignment or hidden dip, right? In connecting roadway tangent gates with an appropriate vertical curve, a mathematical relationship defining roadway elevation at every point is necessary. Okay, now in a curve, everywhere you have to have a mathematical relationship. We use a parabolic function. So they say a parabolic function has been found suitable in this regard because among other things, it provides a constant rate of change and implies equal curve tangents. Then the reason for the traditional preference of parabolic equation is the convenience of manual calculation. Earlier we didn't have computers, right? Even this computer came into being, for the highway design and things, we used it. In Sri Lanka, we used it somewhere in year 2007, right? Year 2007. Maybe you were young kids at that time. So that is the very first instance we used computers for highway design. Before that, you had to calculate manually. Okay, so for manual calculation, of course, a parabolic function was suitable. Now, in other countries also, maybe the computers might have come to the highway industry in maybe in this millennium, in year 2000. Before that, maybe you couldn't, right? So everybody used the manual calculations. And now the basic parabolic equation derived to calculate the elements of a vertical curve is as shown below. Now please write down what are these things. Y is the y-axis. Y-axis, that is normal to the, it is normal to the x-axis. What is this x-axis? It is not along the road. Please understand this very well. Okay. Now give a small blow to your head and understand x is not along the road. X is along the, it is x is along the, how do you call that? It is a, now y is up towards the sky. X is normal to that, right? Then A is the modulus of gradient difference. The modulus of gradient difference, and LV is vertical curve length. So we have defined a basic mathematical model defining a value k as LV over A. LV is vertical curve length, A is modulus of the gradient difference. That means this is G2, this is G1, A is G1 minus G2 modulus of it. Okay, that means only positive values, right? So here you can see L, that is the vertical curve length, right? And what else? So this K is used to indicate the side distance, because you know higher the K, this side distance is going to be increased. So we'll discuss about crest vertical curves. These are the convex vertical curves, which are also known as summit curves. Okay, you know summit, where when there is a mountain, there is a summit, right? So that is why we call it summit curve. In these curves, it is general practice to determine the minimum length by considering side distance or approximately by appearance requirement. So these are some of the crest vertical curves. It can be like this, or like this. It should be, you know, it should be convex, right? And then length of the crest curve is determined using following criteria. The length of crest curve is decided on considering few criteria. What are they? Side distance criterion, appearance criterion, comfort criterion, drainage criterion, and allowable grade change without a vertical curve, right? So, side distance criterion. In providing adequate side distance on a vertical curve, the length of curve is the prime concern. This is the length of curve, LV. Longer lengths of curve provide more side distance. That is understood, right? If you provide more longer lengths, what happens? It's like this. So it would be, so it will have more side distance. All else being equal, but are most costly to construct, right? So even though it is better because you have higher side distances, it is costly to construct. While the shorter curve lengths are relatively inexpensive to construct but may not provide sufficient side distance. So you have to have a balance. In crest curves, it is the vertical geometry of the road that obstructs the driver's sight line. That is understood, right? So if it is going like this, yeah, it will obstruct the driver's sight line. Here, this is the side distance. Can you see? Now, if you are sitting here, you don't know what is happening the other side of the curve, right? So this is side distance criterion. Here, there are two equations. Okay, if this is LV is greater than side distance, here S is greater than side distance. How do you know? At the beginning of the calculation, how do you know whether side distance is greater than curve length, or whether the side distance is lesser than the curve length? Here, how do you know? We don't know. First we assume. First, sorry. First you assume curve length, vertical curve length is greater than side distance, and we use this equation and then check what is LV. So it has to come to satisfy this equation. First we assume this, and then you calculate, and finally it has to satisfy this assumption. If it doesn't, you assume this one, and then you have to follow, then again it has to satisfy that. So usually one of them will satisfy, but you don't worry about this equation, right? Because we have tabulated them. So here, please, there is a small change. Please correct in your notes. This should be stopping side distance. This should be uh, continuation side distance, CSD, and this should be overtaking side distance, OSD. Please correct it. Huh? So here, if your design speed is 70, you have to have a K value of 31 for a crest curve if you have to provide stopping side distance. If you have to provide continuation side distance, it should be 60 K value. K value should be 210.2 if you have to provide overtaking side distance. If it is 50 kmph, if you have to provide, now you know, no, you can't say if, definitely you have to provide stopping side distance. So your K should be in each and every parabolic curve, each and every vertical curve, K should be greater than 9.8. And you know, if you are going to provide continuous side distance based on your budget, it should be, K should be greater than 90.2. And if you are going to provide overtaking side distance in some locations, so your K value should be greater than 89.1, right? So you know, then again there is something called appearance. So what about the appearance of this one? But anyway, this road nicely blends with the environment. Okay, maybe some little bit of exaggeration. Okay, so it is obvious that a vertical curve has little influence other than the appearance of the profile at very small changes of grade. If the grade changes are very small, it is only the appearance. Okay, therefore they can be omitted in the design. So that means rather than having a curve, you can simply connect the two gradients. Shall I draw it? So what they are telling is, if your say gradient is very small, say it is like this, instead of having a curve here, you can directly connect these two gradients. Say this may be say 1.5, this is 1.4, something like that. Okay, but even though the textbooks say like this, as design engineers, we do not recommend. You know why? Have you have you felt that night rider effect when you go on the roads? Huh? So that means you are sitting in the backside of a vehicle. All in a sudden, you are not sitting. You are in the sky, and then you fall down to the sea. That we call nitride effect. Please, please remember that is not some standard or anything. As designers, we call it nitride effect. Don't write anywhere, right? It's nitride effect. Why we call it nitride effect? It is just like nitride that the vehicle is jumping like a high jump. Why that happens? Because there is no curve here, right? It is connected like this. So we usually as designers we do not recommend that, but the textbook says if your the gradient difference is very small, you don't want to have a curve, instead you can connect them like this. So you know they have given if your design speed is 70, if your maximum grade change is without vertical, so the maximum if your grade change is lesser than zero point 0.7, you don't want to have a curve, vertical curve. If your design speed is 50, if your grade change is lesser than 1%, say one is say one gradient is 4%, other gradient is say 3.5%. So your grade change is 0.5%. So you don't want to have a curve, and this is the length of vertical curve for satisfactory appearance. If it is 50, if your design speed is 50, you have to give minimum 50-meter curve length. If your design speed is 70, you have to give minimum 60 meters. Of course, when it comes to civil 3D, uh, we'll discuss them these things in detail, right? And comfort criterion. The length of vertical curve for comfort criterion is provided to minimize the discomfort felt by a human being subject to rapid changes in vertical acceleration. It is usual practice to limit the vertical acceleration to a value lesser than 0.05 into gravitational acceleration. So these are the equations. Don't worry about the equation. Just think this is the k value that is given for the comfort criterion. If it is 40 kmph, sorry 50 kmph, you have to have 6.5 k value, right? If it is 70 kmph, you have to have 13 meter, sorry 13 k value. K value should be 13. But now if you just flip down to your stop inside distance criteria in a vertical alignment, you will understand once you provide the k value for stop inside distance, usually they satisfy for higher speeds. Only for the 30 kmph or something that you have to consider this comfort criteria. In all other speeds, if you provide stop inside distance k value, this comfort criterion is automatically satisfied. Then this drainage criterion, minimum longitudinal grade on curved pavement should be 0.3% for satisfactory drainage. Okay, so you have to have your road gradient should be 0.3% minimum. Okay, don't go for 0.2 or 0.1 or something, because there will be water accumulation. And then what will happen? Yeah, then what will happen? Then there will be aquaplaning. What we mean by aquaplaning? There will be water accumulation, and once the vehicle goes over that, what will happen? There will be water splashing, and the vehicle will not be able to brake, right? Then there is a level point on a crest vertical curve. Do you understand that? Because if it is summit curve, then there is a level point on top of that. But no difficulty with drainage on curve pavement experience if the curve is sharp enough so that the minimum grade of 0.3% is reached at a point about 15 meter from the crest. Okay, that means you have to design in such a manner that in a vertical curve, 0.3% should be reached within 15 meter from the summit of the curve. This corresponds to a K value of 40 meter per percent change in A. Okay, so these things usually we do not follow for national roads. These are some high standards for expressways and things. Then we are going to talk about sag vertical curves. These are the concave vertical curves. Now earlier one, test curves, they are convex, right? And these are concave vertical curves. Okay. In these curves, it is general practice to determine the minimum length by considering approximately by comfort related to vertical acceleration and appearance, and then by drainage, headlight performance, and overhead restrictions to the line of sight. So we are going to discuss them in detail. Now these are type of sag vertical curves, right? Like this, or like this. Okay, and this is a picture of a sag vertical curve. Now, sag vertical curve design differs from the crest vertical curve design owing to the fact that the side distance is governed by the nighttime condition. Now, in the daytime, what about side condition? Now, if it is a crest curve, of course, due to the shape of that, your line of sight is obstructed. But for a sag curve, in the daytime, there is no such obstruction. But what happens in the night time? Night time, the problem is depending on your headlight. Okay, depending on the headlight condition, your line of sight can be obstructed. This is because that the sight distance on a sag vertical curve is unrestricted and daylight. That is understood, right? It's understood. Therefore, the critical concern for sag vertical curve is the headlight sight distance, which is the length of the road illuminated by the vehicle's headlights. So, the length of sag curve is decided on considering few criteria. Okay, same as the vertical curve, but crest curve, but the problem is there is a side distance criterion based on headlight criterion, then side distance criterion based on overhead obstruction criterion. So we are going to discuss them in detail, right? Appearance criterion, comfort criterion, drainage criterion, and allowable grade change without a vertical curve. These are common to sag curves and crest curves, but these two are different in sag curves, right? Here, can you see headlight criterion? So this is how you see, right? This is how you see. So there is an equation to this is S is side distance, right? And now you get the K values. If your design speed is 70, your K value should be 25. If your design speed is 50 for sag curve, right? Your K value should be 12. And then we'll discuss little bit about overhead obstruction criterion. The side distance available on sag vertical curves can be limited by the overhead obstruction such as road or rail overpasses or overhanging trees, etc. This would not interfere with minimum stopping sides. Now you see, now this is a sag curve and there is an overhead obstruction. Now this can critically influence the side distance of sag curve, right? So this of course we cannot tabulate because that there is a difference between the heights. Okay, there's a difference between the heights, so we have to calculate them ourselves. Then other criteria, yeah, other criteria, appearance criterion, they are same as the crest vertical curves. Comfort criterion, the requirements are as same as the crest vertical curves. And then drainage criterion, the requirements are same as the crest vertical curve, right? Then allowable grade change without a vertical curve, that is also as same as the crest vertical curve, right? Now we have to discuss about grades. What do you mean by grades? The grades you are going to get in the university? No, right? Grade means the slope of the road along the road. Okay, so the gradient of a line is its longitudinal slope and is expressed as the ratio of the difference in height of its two ends to the length between them. Okay, so that means grade is h divided by L. Okay, L is the horizontal length. On gradients, vehicles have to change gears and cause disparities on speeds between vehicles. Why? What happens? Can a heavy vehicle travel at the same speed as a personal car in a high grade? No, right? So this affects the quality of service. Now maybe you may be wondering what is this quality of service and things. So because in our country the problem is uh, we do not pay, not the highway engineers, the normal public, general public, they do not pay much attention in the quality of service. If we can get the service, then it is okay. But no, in developed countries, of course, yeah, you have to get the service and there should be a quality of the service also. That is why we speak about quality of service. Now of course in a road, if there is a steep gradient, what happens is, yes, you can trail behind a heavy vehicle, but here it is not the proper way. Okay, because your quality of service is reduced. So you have to have some some strategy or some way to avoid these things. That is why we are discussing these things. Okay. The gradient in the vertical alignment can take different values based on the topography of particular area. To characterize variations in topography, it is generally classified into three regions according to the terrain characteristics. Level terrain. Okay. I think we discussed last time also, but anyway we'll discuss again because many have joined. A terrain where a heavy vehicle can operate in the same speed as personal car is defined as a level terrain. Okay. In level terrain, highway side distances as governed by both horizontal and vertical restrictions are generally long or can be made to be so without construction difficulty or major expenses. Okay. So highway side distances are acceptable. Then there is rolling terrain. A terrain where heavy vehicles operate at a substantially lower speed than a personal car is defined as a rolling terrain. In rolling terrain, natural slopes consistently rise above and fall below the road or street grade, and occasional steep slopes offer some restriction to normal horizontal and vertical roadway alignment. And then comes mountainous terrain, a terrain where heavy vehicles operate at crawl speed. What is this crawl speed? Crawling. Maybe you have crawled in your childhood. Okay, crawling. So that means it goes very slowly. Okay, so as defined as a mountainous. What about now? Just think that you are going to Haputale and there is a heavy vehicle going in front of you and you cannot overtake also. So it is crawling. Okay. In mountainous terrain, longitudinal and transverse changes in the elevation of the ground with respect to the road or street are abrupt, and benching and side hill excavation are frequently needed to obtain acceptable horizontal and vertical line. What is this benching? Shall I show you? Oh, I think I can show in the internet also. Wait a second, right? Can you see? This is the road benching. Okay, there's the road, and then this is road bench. Okay, otherwise what happens? This is one for one to avoid earth slopes, and again for drainage, and other one is to for side distance, right? And standards for grades, the grade adapted should allow the average vehicle to climb mountain on top gear at the design speed or move down without excessive braking. Okay, so that means gradient should be in such a way you don't want to apply excessive excessive braking, and you should be able to uh, you know you should be able to go at the top gear. Therefore, to satisfy above criteria, maximum grade should be defined. Also, runoff water should drain along the road. Therefore, in the places of almost flat terrain, minimum grades are specified, because you cannot go with 0% gradient, right? So these are the maximum gradients. Now, if it is A class road, the flat terrain maximum gradient is 4%, rolling terrain it is 6%, and mountainous terrain it is 8%. Okay, for B class roads, for flat terrain we can go up to 5%, rolling terrain 7%, mountainous 9%. Now in the expressways, what is the maximum gradient we allow? That is 4%, right? That's 4%. Then minimum gradients. Drainage is the main consideration where minimum grades are involved. On flat terrain, the gradient can be flat, provided that normal crossfall is available and length of level gradient is as small as possible. In rural areas, a minimum gradient of 0.5% should be maintained, and in urban areas where pavements are curved, minimum gradient should not be flatter than 0.3%. Okay, so one person is having some internet connectivity problem. So the minimum gradients, if the road gradient is flatter than 0.5%, then the drains must be graded separately from the road center line to obtain a minimum of 0.5% slope. Okay, so that means if the road gradient is 0.5%, then of course is flatter than 0.5%. Just think that it is say 0.3% or 0.2% or whatever. That is also we do not allow. Usually only for very small sections we allow such flatter gradients. Otherwise what happens is there can be aquaplaning. Okay, so anyway, if it is so, what we have to do is you have to grade the drain separately to provide minimum of 0.5% slope. Then sometimes we'll have to go for grades steeper than general maximum. Now, if it is flat terrain, we go only up to say 4% or something. Sometimes, so that usually happens in mountainous terrain. We say 8%, but in Bandarale area, sometimes we have 12% gradients also, because we can't help. Okay, because these roads are not very important roads. So if you are going to go for the proper design standards, that will be highly costly. Cost is number one in any engineering project. Okay, therefore, accommodation of gradients more than the recommended general maximum gradients may be justified in the following situation. So if the following situation satisfied, accommodation of gradients more than the recommended general maximum can be satisfied. What? Comparatively short section. So that should be only for short sections. Okay. Of steep gradients which lead to significant cost savings. Okay, then the number of heavy vehicles are low. Okay, so there is no such a big problem. Difficult terrain in which general maximum gradients are not practical. Okay, what about these? Have you heard about that? There is a country in South America called Peru. That's a mountainous country. So the Americans, they call it wild country of Peru. Wild and mountainous country of Peru. I think the Machu Picchu and is famous what you call the pyramids are there. Okay, so it is a difficult terrain. So the maximum gradients are not practical. So you have to go for steeper grades. Less important local roads where cost of achieving high standard are difficult to be justified. Okay, and then a less important road on a mountainous terrain where maximum gradients are not practical, gradients of 12 to 15% may be satisfactory. Okay, even up to 15% we can go, but in Sri Lanka the maximum gradient that I have seen is 12%.